Okay, last page of the study guide here. So this one, we got a lot of information here. They basically ran the whole test for us. We are just trying to take the results and make an interpretation. So we've got a large school district. There was a claim that the mean math SAT score was 490. And maybe that happened in years past, and that's just kind of what they've held to. So an administrator thinks that the mean has increased. So our null is that it is equal to 490. Our alternative, we now think it's higher. So they took a sample of 25 students and they got a sample mean of 504 and a sample standard deviation of 20.5. They ran the test and they got a p-value of 0.0011. So remember we've said p-value, if it is less than alpha, then we get to reject the null. So that is clearly less than our alpha value of 0.05. So we get to reject the null. And usually that's what we write. So what does that mean when we reject the null? So if we're rejecting the null, we're saying, okay, we have enough information to say this is not true. Therefore, we are accepting our alternative as truth. And the alternative was that it was greater than 490. So we're looking for the one that matches our alternative, and that's what we're going to use for our new assumption now. So this test let us reject the null, which means we are accepting our alternative. Okay, numbers 15 through 18. This is basically just you running a test, okay, a full test. According to Pew Research, internet users 18 to 29, 53% said they use Instagram. We have reason to believe that this is different, so we conduct a survey, test the claim at a level of significance of 0.05. Okay, so null and alternative. H sub O, it is originally claimed that P is equal to 0.53, 53%. We now think that that's different. It didn't tell us how it was different, only that it was different. And our level of significance was given to be 0.05. Okay, so find the critical value, test statistic, and p-value. So your calculator, if you run this test, will give you a lot of these things. It will not give you your critical value. So this is, because it's percents, this is a one prop z test. So we're going to use from the formula sheet, we're going to use this to find our critical values. So I'm going to do inverse norm. It's a two-tail test, so I have to do alpha divided by 2. So my critical values are plus and minus 1.96. So negative 1.96, positive 1.96. Okay, now I'm going to run the test to get my other values. So I'm going to go to stat, test. This is a one prop z test. Original claim was 53%. Let's see, we have 270 out of 532 not equal, and calculate. So here's my new information that I have. My test statistic is negative 1.03 and my p-value is about 0.3. Okay, so on my picture, remembering that this is based on a standard normal distribution, so z is in the middle. So my test statistic is out here, did not make it to the cutoff, and my p-value, 30%, is clearly not less than 5%. So make a decision regarding the null. So the decision that we get to make here is that we fail to reject. So now calculate and interpret a confidence interval. So if we ran a one prop z test, then now what we want to do is run a one prop the interval to go along with it. Again, if you run the test in the calculator, all your information carries over for the interval. So we've got about 47% to 55%. So we are 95% confident that the true percentage of internet users aged 18 to 29 who use Instagram is between 47 and 55%. We failed to reject that, and that supports this because 53 is in the interval. So it is likely that it could actually be 53.